video, I'm going to show you how to balance chemical equations. And this is just one of those things in chemistry that is really, it's much easier than a lot of students seem to make it out to be. Some equations you have like really, long-winded equations that have a lot of molecules and charges and things like that. And, it kind of looks overwhelming. And sometimes, if you do it in your head, you might, balance one part of it, and then that, unbalances another part of it. But there does exist a technique that will lead you to the right balanced chemical equation every time, regardless of the equation. And that's what I'm about to show you. So the idea with balancing chemical equations is we want to make the numbers of each type of atom the same for both sides of the equation. And the way that we do this is by assigning coefficients. Note also that the total charge has to be the same for both sides of the equation. So the total charge on the left-hand side of the equation must equal the total charge on the right-hand side of the equation. It must be balanced both atomically and electrically. So let's get right into an example. Here we have the equation for the combustion of hexane. So we have hexane, C6H14, plus O2 yields CO2 and H2O. Now, the first thing that you want to do is just assign coefficients of 0 to everything. So what I'm going to do is I'm going to put a 0 on every chemical species in this equation. So what we're going to do is we're just going to balance each atom one at a time and sort of keep a running count of how many atoms we have. So, alright, I'm just going to build sort of a small table. Okay, so we have reactants, we have products, and we have carbon, hydrogen, and oxygen. So in these cells here, we're going to keep a running count of how many of each type of atom we have so far as we're balancing. So the first thing that I recommend doing is start with an element that appears only once on either side of the equation. So in this equation, you can start with carbon, you can start with hydrogen, but it wouldn't be good to start with oxygen because oxygen appears twice on the right-hand side of the equation. It appears once in CO2, and it also appears again in H2O. So we're going to balance everything else first, and then sort of implicitly we're going to balance oxygen once everything else is all done. So I'm going to arbitrarily just choose carbon to start with. So we're starting with carbon. Now, what we need to do is identify which side of the equation has the larger number of carbons. And to me, that looks like the left-hand side of the equation has the most number of carbons. It has 6, whereas this side only has 1. So what we're going to do is we're going to take that chemical species that has the most number of carbons, which is hexane, and we're going to give it a coefficient of 1. Okay? So in giving this a coefficient of 1, we've now changed the number of hydrogens and the number of carbons on the left-hand side of the equation. So that means I can fill out my little chart here. It looks like we have 6 carbons, because 6 times 1 is 6. And then we have 14 hydrogens, right, because 14 times 1 is 1. Right now, all we're trying to do is balance carbon, but in so doing, we've just increased the number of hydrogens on the left-hand side of the equation. Okay, so to balance carbon, we're going to make sure that the number of carbons on the right side is the same as the number of carbons on the left side. And the only way to do that is by assigning a coefficient of 6 on the CO2 molecule. So there's my 6. And now what we've done is we have increased the number of carbons and oxygens on the right-hand side of the equation. So now it looks like we have 6 carbons, and it looks like we have 6 times 2, or 12, oxygens on the product side of the equation. So we have just successfully balanced carbon. Carbon's done. Now we can move on to hydrogen. And we're going to use the same method. You're going to look at the number of hydrogens on both sides, and then you're going to identify the subscript that you need, or excuse me, the coefficient that you need to use to make them both equal. Okay? So it looks to me like we have 2 hydrogens over on this side, and then over here we have 14 hydrogens. So I'm going to change the subscript on this to give it 14 hydrogens, and since there's 2 for every water molecule, I'm going to choose 7. 7 times 2 is 14. So now that gives us 14 hydrogens on the product side. But if you notice, we just changed the number of oxygens. It's no longer 12. 12 of them come from here, but now we have an additional 7 from here. And 12 plus 7 is 19. So I'm going to change this guy to 19. Okay? So now we're almost done. We have 3 of our coefficients, and now we only need 1 more. So we have 0 oxygens over here, and we have 19 oxygens over here. And this is an O2 molecule, so whatever coefficient we use, 2 times that will be the number of oxygens that we have. So we have, again, we have 19 over here, we have 0 over here, and there's 2 oxygens for every O2 molecule. So that means we're going to have to multiply 2 by something to get 19. Now, if we use 9, if we use a coefficient of 9, we'll end up getting 18 oxygens, and we'll be 1 short. And then if we use 10, we'll end up getting 20 oxygens. So, and then we'll have 1 too many. So now, in other words, what we have to do is we have to use a fraction. So what I like to do is I just like to say 2 times x equals 19. And then just solve for x, and you'll get x is equal to 19 halves. So now I'm going to put 19 halves over here. And now that just changed our number of oxygens to 19. Now this equation, we've just balanced it mathematically, but it's not really balanced chemically because it doesn't really make sense for a fraction of a molecule to be reacting with anything. So what we're going to do is we're going to multiply everything by that denominator of 2 to get the lowest whole number ratio. So let's go through everything. Multiply everything by 2. 1 times 2 is 2. 19 halves times 2 is simply just going to be 19. 6 times 2 is 12. And 7 times 2 is 14. So there you have it. There is our balanced chemical equation for the combustion of hexane. Make no mistake, you could have started with hydrogen and you would have ended up getting the same thing. And if you want, you can go ahead and check to see if everything is balanced. This table here, simply everything is just multiplied by 2, and that gives you the lowest whole number ratios of everything here. So I hope this helps, and good luck to you.